Okay, so our second video is we're going to be looking at some more of these theorems, these results from this factor theorem. Okay, so the maximum number of zeros, which I kind of hinted on in the first one, so in the first video. So the maximum number of zeros, okay, let's say that you have a polynomial of degree n, so that's x to the power of n plus x to the power of n minus 1 plus dot 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 up to x plus maybe some constant, okay? So if a polynomial of degree n were to have n plus 1 zeros, then by the first theorem above, it would be divisible by a polynomial of degree n plus 1, which is impossible. So basically what we're saying is a polynomial of degree n has at most n zeros. So whatever this degree is the amount of zeros of that polynomial. Okay. Now they can be single roots, they can be double roots, they can be whatever they want, but we just need to know that there has to be that much in total, okay? And there will always be that many, okay? There might be less in some situations, but at most, that will be the most that we can have. So for example, a polynomial of degree 3 that only has 1 zero is y is equal to, or I should say p of something. So p of x is equal to x cubed. This one here only has 1 zero, because this is just the regular cubic that if I was to draw it, looks like this. And that's the 1 0 there. Or that would be the root in that case, because we remember that the root is the zero of a drawn polynomial. Okay, so the fourth one, part D, is a vanishing condition. So the previous theorems translate easily into a condition for a polynomial to the zero polynomial. So suppose that p of x is a polynomial in which no term has degree more than n. So basically you've got a degree n polynomial, yet which is 0 for at least n plus 1 distinct values of x. Then p of x is the zero polynomial, okay? So in particular, the only polynomial that is 0 for all values of x is the zero polynomial. So in other words, when p of x is equal to 0, this is technically a degree 0 polynomial, but it also technically has a value. Sorry, it's a degree 0 polynomial because it's x to the power of 0. No, that's not right. Because there is no x value, because there's no value there at all. But it does have technically got a 0 because it's when it's equal to 0. Or when it's equal to anything, really. And the third one that we're going to talk about is suppose that p of x and q of x are degree n polynomials that have the same values for at least n plus 1 values of x. Then the polynomials p of x and q of x are identically equal. That is, they are equal for all values of x. So basically, if you were to put in... we'll just have a look at an example of this, because I think it's much easier to show an example. So the last one... I'm not really writing anything for these, but the last one's basically saying, if all the values for your polynomials are the same, then the polynomials must be the same. Like, there's nothing tricky about that. Anyway, let's have a look at an example. Find a, b, c, and d if x cubed minus x is equal to a lots of x plus 2 cubed plus b lots of x plus 2 squared plus c lots of x plus 2 plus d for at least 4 values of x. So, what we're going to do is, because they are equal for the four values of x, they are identically equal, okay? So, what we're going to do is we're going to start off by substituting in, well, in this case, we're going to substitute in minus 2, because what that's going to do is it's going to produce a value for d for us. So, let's write substituting x is equal to minus 2, we're going to get x cubed minus x, or in this case it should be, not x cubed minus x, it'll be minus 2 cubed minus 2 is equal to a lots of minus 2 plus 2, so 0 in other words, plus b lots of minus 2 plus 2, or 0, in other words, plus c, lots of minus 2 plus 2, or 0, in other words, plus d. Okay, so the right-hand side's nice and easy because this is going to be 0 in here, that's going to be 0 in here, and that's going to be 0 in here. So all those terms will cancel out, and we're going to be left with the d. And on the left-hand side, we've got minus 2 cubed, which is minus 2, positive 4, negative 8, minus minus 2, so that's minus 6. So d must be equal to minus 6. Now what we're going to do is we're going to equate the coefficients of x cubed, okay? So in other words, we need to know what the x cubed term is going to be. In this case, okay, if I was to look at the first bit, this a lots of x plus 2 all cubed, I can only get an x cubed value from this, okay? So let's expand that out. So a lots of x plus 2 all cubed, well, that's equal to a lots of x cubed plus, well, I better do it the long way. X plus 2, lots of x plus 2, lots of x plus 2, like this. So this is going to be equal to a lots of x squared plus 4x plus 4, lots of x plus 2, which is equal to a lots of x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. Okay, and then putting that all together, we're going to get x cubed plus 6x squared plus 12x plus 8, like that. Okay, so expanding that out with the a's, a lots of, well, it's going to be a x cubed plus 6ax squared plus 12ax plus 8a, just like that. Okay, and what you'll notice is amongst the other terms, it is not possible for us to get an x cubed value. So the only value of x cubed I can have is this part here, okay? And so this part is going to be equal to a specific value, okay? So that ax cubed must be equal to, and if we go back to our original polynomial that we're trying to decompose, it has to be equal to this value here, which is that x cubed value. So if it's just equal to x cubed, okay, so what value of a makes this equation true? A times x cubed is equal to x cubed. What does a need to be? Well, if we divide both sides by x cubed, we get a is equal to 1, okay? And there's our second value. So we've got two values already. We've got d is equal to minus 6, and we've got a is equal to 1, okay? Now what we're going to do is we're going to find our values for b and c. So the way that we're going to do this is we're just going to substitute any value into this side here. And we're just essentially going to come up with some simultaneous equations which we'll be able to solve. So let's pick some easy ones. We'll pick 0 and 1. So let x be equal to 0. We're going to get a lots of 0 plus 2 cubed plus b lots of 0. Oh, and this should be equal to 0 cubed minus 0 as well. Forgot to add that in. Plus b lots of 0 minus plus 2 squared plus c lots of 0 plus 2 plus d. Okay, so expanding this one out, we're going to get 0 is equal to, well, we already know that a is equal to 1, so we're going to get 1 lots of 2 cubed plus, well, we don't know what this is, b is, so we're just going to leave that as b, as 4b, because it's 0 plus 2, which is 2. 2 squared is 4, so 4b, plus 2c, and d is equal to minus 6, so we're just going to substitute that in. So putting it all together, we're going to get 0 is equal to 8 plus 4b plus 2c minus 6, or 0 is equal to 8, 0 is equal to 2 plus 4b plus 2c, or minus 2 is equal to 4b plus 2c. Okay, we're going to leave that there for now. Okay, and we're going to come back to that in a moment. What we will do first is we will now try it for another value. So back up to the original equation, let's put another value into this original one, and let's just say 1. Okay, so let's put 1 in. So let x be equal to 1. Okay, because it doesn't matter. As long as it's not a 0, which in this case, on the right-hand side, it's only minus 2, which is the 0. So we can put anything in. So let x be equal to 1. So we're going to get 1 cubed minus 1, which is equal to 0 again. That's nice. Okay, a we already know, but I'll just write it out the long way. 1 plus 2 cubed plus b lots of... Actually, you know what? Let's not use 1. I've got a better idea. Let's use minus 1, because it's going to give us a closer number. Well, it's going to give us easier numbers. Okay, so it's going to be minus 1 cubed minus 1. So that should be equal to 0 again, I think. Doesn't really matter. Now we get a lots of minus 1 plus 2 cubed plus b lots of minus 1 plus 2 squared plus c lots of minus 1 plus 2 plus d. Okay, now substituting things we know and rearranging it. So we get minus 1 cubed is minus 1 plus 1 minus 1. So that's going to be equal to 0 again. A, as we remember, is equal to 1. So that's going to be 1 cubed plus b lots of 1 squared. So 1b. I'll tell you what I'm going to do. I'm just going to put the values in. So 1 plus b minus 1 plus 2 is just equal to 1 again. So it's c. And d is equal to, not plus, but minus 6. So what we're going to get is going to get 0 is equal to minus 5 plus b plus c, or in other words, 5 is equal to b plus c. So we've got two equations now, which we can find a and b for. And if I put one underneath the other, okay, and I multiply the 2 by 2, I'm going to get 10 is equal to 2b plus 2c. And what we can do is we can subtract both these equations from each other. That's going to end us with minus 12 is equal to 2b, okay? And the 2c is going to cancel out with the 2c, and so that b is going to be equal to minus 6. Okay, now we know that b is minus 6. We're going to substitute it back up into this one. We're going to get 5 is equal to minus 6 plus c. Okay, and once we've done that, we're going to just rearrange it for c, because it's a really easy one. So plus 6, which is equal to 11. Okay, so therefore, a is equal to 1, b is equal to minus 6, c is equal to 11, and d is equal to, what was d? It's minus 6. Okay, and those are the values that make the above equation, so this original equation up here, so this side, so basically a is 1, b is minus 6, c is 11, and d is minus 6. If you use those and then expand this out, you will end up with the left-hand side there. So with that being said, that's going to be the end of this part of the video, okay? And we are going to move on into the identically... well, basically we can talk about it now. So just to clarify, if two polynomials are, you know, I'll wait till the next one. But basically, you can find what the two polynomials need to be equal to, or the values of the coefficients to make them equal, okay? So it's nothing hard, it's just a lot of algebra. But with that being said, I'm going to leave it with that, and I'll talk to you in the third and final video for this little set.